When it comes to big data, the aim of our Aqueduct product is not only to store all the data all the time, but also to make it both cheaper to store and easier to extract value. So to achieve this, we first see data originating from external systems and flowing into our system via infrastructure that we call aquifers. Here, infinite amounts of data are ingested in a fast and cost-effective manner, ready for real-time analytics. Once that's done, the aquifers present the data in consolidated information to be used downstream for further processing by other data frameworks. After the data has been ingested via the aquifers, it flows via Kafka, a data broker that provides a reliable messaging backplane from which we can consume data at variable rates, and then passes on through another data framework that we call Castellum. Castellum acts as a reservoir, a generalized store that provides in-memory processing and in-memory representations of the current state of data passing through. And this is all backed by a database called Cassandra, which ultimately becomes the global store. Alongside that, we have our geotemporal indexing service, which lets us provide an overlay and coding of the data that relates it to time and space so that we can correlate it with different datasets and derive new valuable insights. Next, we have Aqueduct, which is used to manage and set up the ability to extract information. Essentially, Aqueduct is a triggers framework. If some data source that we're monitoring conforms to a certain rule we provide, then a notification can be sent out in the form of an event or file or a stream of data to an external system. And with the CEP engine alongside Aqueduct, which allows us to perform predictive analytics, we can also see that Aqueduct is more focused on the operational side of real-time complex event processing. Lastly, we have Fontana, an aggregate of several different technologies and capabilities, where we use dashboards to visualize the data and notebooks for further collaboration. This speaks to the data science aspect of our environment, and it allows end users to find value in the information presented, enabling them to make more accurate predictions and informed decisions, and help them develop complementary systems to provide more insights. So that gives us the broad spectrum of where Aqueduct fits in, along with any data lake implementations. It could feed in data, it could consume data, and it could generate events and triggers that can go into the outside world, where there could be some external system responding.